Radiation occurs when an energetically unstable isotope of an element tries to become more stable by emitting particles or energy from their nuclei. Isotopes of elements with atomic numbers of 20 or more usually show this unstable characteristic because their nuclear forces cannot offset the repulsive forces between the positively charged protons. What happens is that the nucleus emits small particles of energy called radiation. For most types of radiation, there's a change in the number of protons or the atomic number in the nucleus, which means that the atom is converted to a different element. The more commonly found radiation are alpha, beta, and gamma. There are about 2000 different isotopes known. Of this, only 279 are stable, meaning they do not change over time. All the other isotopes are called radioisotopes because their nuclei will decay over time and release radiation. This is a spontaneous process, which means it occurs without any intervention. Radioactive isotopes can be identified by either their chemical symbols or writing their mass number after the element's name or the symbol. For example, iodine 131 can be represented in three different ways. Uranium 235, lead 210, radium 226, and bismuth 214. There are several forms of radiation. The more generally found are alpha, beta, and gamma. An alpha particle is essentially a helium nucleus with 2 protons and 2 neutrons. It also carries a charge of +2 and a mass number of 4. Under certain conditions, a large nucleus may give off these particles. A beta particle is essentially an electron with a negative charge and 0 mass. Beta particles are much smaller than alpha particles. Gamma radiation is produced from the release of pure energy from a nucleus. A gamma ray has no mass and no charge, so it's simply a stream of high frequency energy. Radiation is measured in several ways, like radioactivity, absorbed dose, and biological damage. Radioactivity is measured by Curie and Becquerel. A becquerel refers to 1 decay of radioactive material per second. The Curie is a larger unit and is equal to 3.7 times 10 to the power 10 becquerels. The absorbed dose describes the amount of radiation absorbed by materials such as body tissue. The rad measures the radiation absorbed by a gram of body tissue. Gray is a larger unit that measures the absorbed dose in terms of joules of energy per kilogram of body tissue. 1 gray is equal to 100 rads. Rem and sievert are units that measure the biological damage caused by radiation. 1 sievert is equal to 100 rem. Biological damage occurs due to chemical changes caused by radiation at the cellular level. DNA is the primary target for biological damage. The exposure to radiation can directly harm the individual exposed, or the genetic mutations caused by the ionizing radiation can affect their offspring. Immediate results are radiation sickness and death. Sometimes the results may be delayed, for example, cancers and fetal abnormalities, which may eventually lead to death. We should take proper measures to protect ourselves from radiation, especially when we are aware of such exposure. We should take measures to properly shield ourselves. Alpha particles have the largest mass and charge and are therefore able to travel only a few centimeters in air and only a fraction of a millimeter into biological tissues. Protective clothing like regular lab coats and gloves and even our skin is capable of shielding against alpha particles. Typically, radium-226 emits alpha radiation. Beta particles have a very small mass, therefore can travel much faster and farther than alpha particles. They can travel several meters in air and a couple of millimeters into the body. Heavy clothing like thick lab coats and gloves can protect against beta radiation. Carbon-14 is a source of beta particles. Gamma radiation essentially has no mass and no charge and can travel great distances through air and many other material. It penetrates deeply into our bodies and cause much more damage than alpha and beta particles. Dense shielding like lead and thick concrete are needed to stop this type of radiation. Technetium-99 is a common source of gamma radiation.